We now have Professor Mahesh Tirumkudulu from the Department of Chemical Engineering, who will be speaking about his project, Novel Tire Sealant for Tires and Tubes.
Hi, good afternoon to all of you. I'm Mahesh Tirumkudulu, and I would like to present to you some of the work that we have done under our Tata project. Our team consists of Professor Jyoti Seth and Professor V.A. Juvekar, both of them are here. And it also includes two very talented project staff students. You can't hear. Okay. Yeah, now it works. Okay. Right. So as I was saying, our team consists of Professor Jyoti Seth and Professor V.A. Juvekar, who are here. Also consists of two very talented students, the project staff students. One is Shruti Vaze, who was here for the initial part of the project, and currently it's Shirley Mehta, who's been working with us for a little over a year or so. So the main objective of this particular project was to make tire sealants. Now, what are tire sealants? Tire sealants are these liquids that go inside a tire or a tube, which would seal any puncture that occurs, and it happens instantaneously so that there is almost no loss of air pressure. Okay? So there are two different types of tire sealants. One is an inbuilt sealant, in where when the tire itself is manufactured, the sealant goes inside the tires. It's one of the layers, so that if there's a sharp object that goes through the tire, this liquid comes out and seals the puncture immediately. The other one is a mobile sealant, which is essentially a liquid that is put inside a tire, which is shown right here, so that if there is a puncture, this liquid will get thrown out into the puncture because of the very high pressure inside the tire, and is expected to seal the puncture instantaneously so that you can continue to ride your vehicle. Our focus was on mobile sealants for both tubeless tires and tube tires. Now, tube tires would be like bicycle tires, where there's a tube inside and the tire outside. A tubeless tire is what most of the cars and trucks have today. They just have a tire. There's no tube inside. Okay, so how do these sealants work? They work by what is known as a log jam principle. So this is essentially the same principle by which our drains get choked. So here is an image of a drain which is partially choked. So what you have are fibers of different lengths and also particles and leaves of different sizes. And what it does essentially is to completely block the drain and therefore seal it. That's essentially what is there inside this liquid. It contains fibers and particles of different sizes and shapes. And also this is suspended in a viscoelastic liquid. So the liquid has both flows like water, but also is elastic like rubber. And so whenever there is a puncture, this liquid is pushed out at the location of the puncture. These fibers would form a network at the puncture site, and the particles will then fill the gap between these fibers. And the polymers that are present in the liquid strengthen the network by bridging both the particle and the fibers. Okay, so here's just a schematic. I should mention that the very first patent on this came out in 1986, so it's more than a 30-year-old product. But why are we still interested in looking at it? The reason for that is most of the sealants that are there in the market, a few in India, are all water-based. What it means is that if you put this sealant inside your tire or tube, they would actually dry up within about a few months, 3 to 4 months or so. The viscosity of water or glycol-based sealants which goes in there, it varies significantly with temperature. So what it means is if there are extremes of temperature, very cold to very high temperatures, the viscosity varies, due to which in many cases these sealants would not work. And most sealants can seal up to 8 mm puncture holes. So what about if there are larger punctures? When I said 8 mm, it means that if there's a nail of a diameter of 8 mm, that is what it can seal. So there's a need for an environment-friendly, economical, non-water-based sealant that can seal large puncture holes over a wide temperature range. Okay, so now let's look at the economics of vehicles in India. So here is a pie chart that shows in millions the number of cars, cycles, two-wheelers, both that use tube tires and tubeless tires. And if we look at the amount of liquid that goes into these tires or tubes, for each of these, we will get the corresponding amount of the volumes of millions of liters that would go on in each of these vehicles. If we put it all together, we will know, well, if everyone were to put it, we'll get to know what the total amount of these liquids are required. But what is the relevance of this to the Indian conditions? We know that except for some major cities in India and maybe some towns, most of the places in India, especially small villages and so on, have very, very poor road condition. Okay? And so the punctures are very, very frequent. Therefore, there's a very large market with no reliable sealants. Most sealants that are available, which work very well, are imported, are expensive, but typically, again, they're water-based, so they tend to dry up. Okay? And so here we have a small calculation saying that of all those vehicles, even if 10% of them were to use it, we get a certain amount, and there's quite a large market for such kinds of products. So what is our solution to this? So what we have been able to do is come up with a novel tire sealant, which is oil-based, but is also environmental friendly. And in our test that we have done, and which I'll show at least one of them, it seals about 5 mm punctures for tubes. So these are bicycles. So you take 5 mm diameter nail and just nail it into the inflated tire, and you pull it out and see if it actually seals it or not. So it works. And for about 10 mm for tires, these are tubeless tires. The best commercial sealants that we see claim, in fact, less than 5 or 3 to 4 millimeters for tubes and 8 mm for tires that are available commercially. It works over a very wide range of temperatures, and we have tested this in lab from minus 25 degrees to 80 degrees, so the extremes the locations that I show here. They never dry up. In fact, they will exceed the lifetime of the tire, in fact, exceed the lifetime of the vehicle itself. It will not corrode the metal rim, unlike some of the water-based sealants could. It's a very, very simple processing step. In fact, you could set up a small, on a table and get easily about 200 to 300 liters per day in a very, very small area. And we think it's economical. As of now, the raw material cost is about 700 rupees per liter if you put everything together. But we still think that this price is on a higher side, so we are trying to look at options where we can replace the current materials with something which is cheaper, so we can drive this cost down. The imported sealants that are available in India, which work very well, cost about 2,600 rupees per liter. We have filed for an Indian patent based on our invention. So we've done a number of tests, as I said. In fact, what I show here is a schematic of our experimental setup. It consists of a cylindrical tube, which is sealed on both ends. On one end, we have a pressure gauge, and the other end is sealed with the tire or the tube itself. And at the bottom, we have a bevel gear, which is then connected to a platform on which we can insert nails of different diameters and, in fact, puncture them and then look at the change in pressure as a function of time to see how successful a sealant is. And this is very useful to actually vary the formulations and then look at how well they work, rather than trying to puncture a scooter tire or a cycle tire each time. Once we zeroed in at a particular formulation, then what we did is to put it inside a car and we punctured it with a 9 mm nail. We've driven it on expressways, for a very long time. In fact, the car has been running for more than a year without any perceptible change in pressure. I mean, when I say that, I mean the one which was punctured compared to the one which was not, there's hardly any change in that, a difference in that. We have also done the same on cycle tubes and tires, and we find that it works up to 5 millimeters. In fact, my bicycle that I ride very regularly, both the tubes have this sealant. And one thing that I've observed is that the air filling frequency has come down, because even if there's a minor leak, it goes and seals it. So here is a movie which actually shows one of these tests done on a 4 mm nail. You can see that this person takes a 4 mm nail here and hammers it into the inflated tire, and it takes it out. Yeah, we'll play this again because I think there's a problem with the thing. I'll show it again. Here is a tire, the nail which he hammers into an inflated tire, cycle tire. And you just have to rotate it once so you ensure that the liquid is coated inside. And there is. So there's a very small amount of liquid, just a drop of liquid that comes out and immediately, instantaneously seals the cycle, and you can just continue to ride this bicycle. In fact, in our test that Shirley has done, she has taken the same tire and hammered nails 5 or 6 times on the same tire and continued to ride it. There's been no problems. Okay. Next one, please. So what is the future work? So I think now we are ready for field trial of this sealant in different road conditions. The roads that we have tested it on, at least on the bicycle, are IIT roads, which are actually very nice, but we need to do it on roads which are not that good. So what I mean is rural areas, even off-road, mountain bikers and so on, daily commuters. We also need, therefore, to conduct a survey through these trials in order to gain insight into the performance of the sealant. And then with the feedback that we get from there, we might want to tweak the current composition. And one of the other things that we want to do, of course, is to identify and collaborate with investors who would like to commercialize this product. So with that, I would like to end the talk, and I'll be happy to answer any questions. Thank you. Yes. Sorry. Oh, sorry. You'll need to give a mic. You can use this mic.
The biggest problem for waste managers is glass punctures in compost plants, glass punctures of tipper trucks and compactors and JCBs and so on, heavy vehicles. Have you tried using the sealant on big tires which cost 20,000 each to repair?
No, we have not done that. So I think that is something that we'd like to do. So what we have done, our tests are on cars, or one car in fact. We have done it on scooters, and we have done it on bicycles. So that is something that we hope to include as part of the test itself.
Yeah. I was telling you all yesterday about how a small 1 lakh interest-free loan repayable in a year can boost up an innovator's activity. The first person who benefited with a Palle Srujana loan was Kantale Pandurang Rao in near Hyderabad, in Telangana somewhere, Sukotirth village, who is selling punctureless tubes as a business for motorcycles, because farmers stranded far from a repair place would have to push it all the way home. So you might want to connect with him. I have his contacts.
Thank you very much for that. Yeah, thank you.
Sir, what is the quantity of sealant used for a tire? Inside
So-
it is filled?
Yeah, so we want a few millimeters thickness of this layer inside the tire or the tube. So for bicycles, it turns out to be about 120 ml. And one of the concerns, I don't know if that's where your question is leading to, is what is the effort that is required to bicycle the tire now that you have an extra load on the bicycle, because the torques increase. What I felt is that it's not very excessive. One of the concerns is that the rolling resistance of the vehicle actually increases. What it means is that you require a larger torque to rotate. But bicycles, at least, which is human powered, so where you can feel it, I don't feel a significant difference. And so that's what it is, yeah. Right. Yeah. So the question is whether it sustains, whether we can seal the puncture at all temperatures, wide range of temperatures. We have done that in the lab, but we have not taken our sealant, put it in a car and driven really to Thar Desert. We have not done that, but we have done the test in the lab where we heat up the entire setup to that temperature, sealant, everything, and then we put it and then puncture it, and it surely works. Because the very properties of the fluids and the particles, fibers that we have chosen is such that they don't get very influenced by the temperature itself. That was one of the main things that we were aiming at when we were designing it.
Thank you for the presentation. A quick question.
Yes,
Could used car engine oil be used to make this sealant or conditioned in some way so that you could do it? I'm looking at using waste from the same industry to make your sealant.
Well, as of now, I can't think of. The reason I'm saying is that this particular the base liquid that we have is just not an oil, although I say that's what it is. There is a reaction step that is included in it. And therefore, offhand, I will not be able to answer that question. Yeah, yeah. Yeah. Right, yeah. Yes, very easily. In fact, you can, for bicycles, you can fill it yourself, but for scooters and cars and all, you'll have to go to a mechanic to do that. Cars especially, because if it's a tubeless tire, you'll have to take it off from the rim and then put it inside. That's difficult for us to do, so for that we'll have to go. They may. Well, I don't know. Yeah, possibly. Yeah, yeah. Yeah. No. So there is no reaction that takes place at all. As I said, that it works on the so-called logjam principle, where you have a hierarchical structure. So you have fibers, particles of different shapes and sizes, so that what happens is the large holes get blocked by smaller large particles, the gaps between the large particles then get blocked by smaller particles and so on. And then finally the liquid tries to escape through the smallest gap, but the properties of the liquid is such that it has both a viscous and elastic property that it actually just gets jammed inside completely.
The existing wall allows this? So the existing
Yes, it does.
walls?
Yeah. You can just open it and done it. Yeah. So we have tested, as I said, on cycles, scooters, and cars. It's easy. It's doable.
Thank you.
Yeah.
Thank you.
Thank you.
What is the life of rubber in contact with this thing for how many years? Like, will it soften or spoil?
Yeah. So the material that we are using will not influence rubber in any way. That's for sure. Yeah. That's what we think.